This is Physics 1 course. In this video, I will solve another example on a constant acceleration motion. So, a submarine starts its engine when it is 100 meters underwater and moves upward with constant acceleration. It arrives the surface in 3 seconds. What is its acceleration? If only at surface it turns off its engine, how far above the surface does it go? Let's first draw a coordinate system. That's the first thing we need for every problem. So here is the submarine. Here is the surface of the earth. And this is the y-axis. And this distance is 100 meters. 100 meters. And it moves upward with a constant acceleration. So, as I said, whenever we work close to the surface of the earth, there is an acceleration called g, or gravity, which has 9.8 meters per second square. But the problem is, here the submarine has its own engine, so it's not a free fall, or it's not a free motion. It has some force being applied upward. So the combination of these two is making an acceleration called AY, and it's unknown. It asks us to find it. What is the acceleration? So basically this acceleration is a combination of all the accelerations due to the gravity, due to the engine, and also due to friction of water, because here there is water under the surface. So if I put the x-axis here, I could do x-axis here, but let's do it here. It doesn't matter where I put the x-axis. The final answer should not depend on how I choose my coordinate system. So if I do it here, then y naught would be 0, because the submarine starts at from 0, and when it arrives at the surface, it takes 3 seconds. So let's say t1 equals 3 seconds, and y at t1 equals 100 meters. 100 meters. So now let's use the equation y t1 equals y naught plus v y naught t1 plus half ay t1 square. So we know this one is 0, this one is 100 meters, and so now it doesn't tell us what Vy naught is. It only tells us that moves upward with constant acceleration. So we can assume that Vy naught is 0. So it started when it was at rest, then suddenly starts the engine. So this one is 0. And now we want ay. So this t1 is, so let's say this is equal to 0 plus half ay, and t1 is 3 seconds. 3 seconds square. So therefore 2 times 100 meters, 2 times 100 meters divided by 9 second square equals ay. Therefore ay equals 200 divided by 9 is 22.2 meters per second square. So this is the answer to the first question. If only at surface it turns off its engine. Therefore, when the submarine is here, there is no more friction from water, which was there, and also this other force is off, so there is only gravity. So we know AY is negative 9.8 meters per second square at this time. While this underwater, it was positive. So it was like the net force was upward, but now from here on, the net force will be downward. That's the reason for the negative. When solving this, the second part of the question, we would like to reset our stopwatch. It is easier to start from time 0, assuming that time is 0 when this guy is here. And also we need Vy naught, means the speed of the submarine upward at this time. So before going to this problem, let's go back to the previous problem and find the speed of the submarine when it arrives here. That speed will be the initial speed for the second problem. To find the speed, we have to use the other equation from previous video. Vy equals Vy naught, which we said is 0. So it's 0 plus Ay T. So T is T1 because we want Vy when it is here. So Vy at time T1. And Ay is the same as here. So it is equal 0 plus 22.2 meters per second square times T1, which was 3 seconds. So 3 seconds. So therefore it is equal to 666 meters per second. Now let's go to the second question. So Vy naught for this problem is Vy at this position from the previous question. So therefore Vy naught equals 66.6 meters per second. So we want to solve Vy minus Vy naught equals, or let's say it's equal plus Ay T2. So at time T2 I said the submarine, which is now at the surface at time 0, so this is T naught equals 0, and this is Y at time T2 it arrives the maximum height. So when it arrives the maximum height, it just stops for a moment and then goes back. So therefore Vy at T2 is equal to 0. Therefore 66.6 meters per second plus Ay, I said it's minus 98 because it's only gravity under gravity again. So the Ay is now that, and T2 we don't know it, we're gonna find it. So it is equal to 0. Therefore T2 is equal to 66.6 divided by 9.8 and seconds. So I just took this the other side, then divided both sides by 9.8 meter per second square. So this is T2, Now let's say y equals y naught plus vy naught t2. So I want y at time t2. That means I want this distance, the maximum height. ay t2 square. So for the second problem, I have moved my x-axis here, so therefore y naught is 0 again, plus vy naught we just found, 66.6 times meters per second times t2, 66.6 divided by 9.8, and this is only seconds, plus half times minus 9.8 meters per second square, and time is 66.6 divided by 9.8 second square. So it is equal to, so notice that this is twice the other side because of this half. So it is equal to half 66.6 square divided by 9.8 meters, which is equal to 226.3 meters. For the problems in physics 1, we usually do not need to worry about air friction. It is usually negligible, and almost in most of the problems we neglect them. Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.